Assalamu alaikum to all of you. In the previous lecture, we have discussed about the spectrum and its two types, continuous spectrum and line spectrum. The spectrum is band of colors for the visible light, and for the electromagnetic radiations, it is the series of frequencies and wavelengths that is known as a spectrum. So we have discussed earlier two types of spectrum are, one is continuous, in which there is no any line of demarcation between the colors, or the spectrum in which there is series of frequencies and wavelengths, that is known as continuous spectrum. And the line spectrum is that in which there is line of demarcation, or in which lines are and frequencies or wavelength are in a quantized manner, means particular frequencies and wavelengths are obtained, so that is named as a line spectrum. So today we will discuss about the types of line spectrum, are the techniques that upon which atoms can be discussed, are the spectrum upon which atoms can be studied. Okay, so line spectrum we have discussed earlier. So line spectrum has two types. One is line emission spectrum. Line emission spectrum. Other one is line absorption spectrum. Okay, these are the two techniques. So line emission spectrum, from the word emission, it is clear that emitted light is focused. Emitted light is focused is called line emission spectrum. The line emission spectrum, let's say if we have let's say sample, or let's say we have a sample which we have discussed, okay, which we have to study, this is a sample, and in the sample there is certain gas, okay, there is certain gas which is the source of line spectrum. Okay, this sample we have to excite it, or we have the heating it, we have to heat it. Okay, in this sample we provide the heat, or we may excite it by other means as electrical, providing electricity. It also can be excited, or by providing heat by means of other methods it can be excited also. So simply we are exciting whatever we take the method, we excite the sample of gases. Okay, when the sample absorbs the heat, after absorbing the heat, the electrons of sample get excited to their higher energy levels by absorbing the energy, and when the electrons reach in the higher energy levels, they become unstable. Because of higher energy they become unstable, and those electrons want to be stable, and only the way of stability that the electrons must lose the energy which they have absorbed. So by emitting the absorbed light, they come back towards the original position or the original energy levels. So these are the radiations which are emitted. It means this is the emitted light which we have to focus. This is emitted light. Emitted light which we have to focus, and the light will scatter or will diffuse in different directions. So the radiations, these are emitted by the gas. This will go in different directions. So if these rays are scattered in the different directions, then it will be difficult to focus and to get the spectrum. So for that we have a small construction. We have to place a slit. This is a slit, and what is slit? Slit is the narrow opening for the passage of light. Slit is narrow opening for passage of light is known as slit, and along with it we have a convex lens. Okay, a slit and the convex lens, this is known as collimator. This is known as collimator. Slit plus my convex lens is known as collimator. So when these radiations pass from the collimator and the radiations are diverging, these radiations are diverging radiations are the diverging rays. When they pass from the collimator, all the radiations show same behavior, means they will be parallel to each other. These are the radiations parallel to each other after passing through the collimator. So what is collimator? Collimator is the construction which consists of a slit and a biconvex lens, and its function is to convert the diverging rays into parallel rays. So collimator converts the diverging rays into parallel rays. Is called collimator. Okay. After passing through the collimator, we may have a prism, or we may have let's say, okay, but simply we take a prism. This is a prism, and the radiations will pass through the prism, and all these radiations will diffuse. Okay, diffuse in different directions, diffuse in different colors. So we take a single ray. Let's say this is a ray which is split up into the different colors, and the different colors we have observed in the emitted or the spectrum. So for observing these colors, we must have a telescope. This is an objective lens, and other one is, this is eyepiece. This is, let's say, this is eyepiece. Okay, so this is eyepiece, and we will observe the colors. Okay, in emission spectrum we have focused the emitted light, and the emitted light, the brightness appears against the dark background. It means that in emission spectrum the background is dark and the emitted light that are focused are the bright. So we can take K in line emission spectrum. In line emission spectrum, bright lines are obtained against dark background. The dark background means the region where is no light present. That is known as dark light or dark background. Sorry, not a dark light. Dark background means unavailability of energy. Dark is the point where is unavailability of energy, are the light, and the brightness are those points where is the availability of lines. So the lines at which positions these are present, these positions must be bright, and the lines where are absent, so there must be a darkness appears. So the in line emission spectrum, the bright lines are obtained against the dark background. So this is a line emission spectrum. After it, line absorption spectra. In line emission spectra, we have focused the emitted light, while in line absorption spectrum, we have to focus the absorbed light. Absorbed light we will focus in line absorption spectrum. Okay, so line how we will focus the absorbed light. For that we take a sample whose spectrum we have to study, and for that we will take a source of light which should be continuous. Let's say we have a continuous source of light. Let's say K. We have a continuous source of light. This is continuous source of light, or let's say this is a continuous source of light. This is continuous source of light which emits the light. Okay, this emits the light, and in the light all the frequencies and all the wavelengths are present. So that's why it is considered as a continuous source. So continuous source of light is okay, continuous source because of it contains all the frequencies and all the wavelengths. Okay, and after that we have taken a sample which we have to study. Let's say we take gas, any atomic gas. This is gas. Okay, this is gas. So when the gas is placed in the path of light which is emitted by continuous source, so it will pass from the gas. Some of the wavelengths of light are absorbed by the gas, and some of and remaining other gas which is not absorbed by the gas, they pass from the gas. So the radiations which pass from the gas and not absorbed, so these are the radiations are the we may say rays which are not absorbed by the gas, this will appear as a bright points. But we have to only focus the light which is absorbed, and the light which is absorbed by the gas, that wavelengths and frequencies must be not present in the final spectrum. So at those points, are we may say those wavelengths are the frequencies, are those rays which are absorbed by the gas. These at these positions they will appear as the dark points or the dark background. So and the lines which are not absorbed by the gas, they will appear in the final spectrum. So and finally, in this situation, when the gas absorb the light, it may get excited, and after exciting, it may give out the light. So to take prevention from it, we must have a coolant system. This is coolant. Because of by absorbing the light from the source, gas may heat up, and by heating it may emit out the same radiations which are absorbed by it. So by getting the prevention from the heating or the emission of light, we take it a coolant system. When the gases is heated, those radiations are those heat is radiated by or absorbed by the coolant, and its emission is not allowed because of emission will not take place. Okay, so these radiations are those radiations which are not absorbed by the gas. So and the radiations which are absorbed by the gas, at these positions, these are the vacant places and they appear as a dark points. It means these radiations which are not present here, these are absorbed by the gas, and we have to observe those radiations which are absorbed by the gas. So by absorbing these, we will take same situations, and this K we place a collimator in front of these. Okay, we will place collimator, and the collimator will convert the diverging rays into parallel rays. Again we will take a prism, and each ray will diffuse into different colors. Okay, and the radiations in this kind of spectrum, we will focus only the absorbed light. The light are the rays which are absorbed by the gas. At this final spectrum, at those points we will obtain the dark lines. So in line absorption spectrum, dark lines are obtained against bright background. Okay, so this is line absorption spectrum, and these are the two techniques through which we study about the atoms. Okay, thank you.